quantum computers. The idea of a quantum computer has been around for around 30 years, but it is only recently that we have seen experimental progress in this area. So, Akanksha, what is a quantum computer?
A quantum computer uses quantum mechanics to process information. It also uses quantum bits, or qubits. Qubits are a pair of entangled quantum particles. Why a quantum particle? It's because of superposition. It can be in multiple states at once. We use a pair of particles for one qubit to view a quantum particle as it changes its state. We also need it to view it indirectly. How to view it without affecting it? We can entangle it with another particle. See the changes of state in the particle to understand the first. So why qubits? Due to superposition, they are capable of carrying out millions of calculations simultaneously. Classical computers use 0 or 1. It is capable of calculating one thing at a time.
One of the more exciting characteristics of quantum computers is that they scale exponentially. This is in stark contrast to classical computers, which scale in a linear fashion. In order for a quantum computer to perform calculations, it needs to pass the qubits through logical gates. The logical gates a quantum computer uses is called a C-naught gate. The logic of the C-naught gate is similar to the XOR gate in classical computers. Quantum computing, while still very new and still in the experimental stage, does have a commercial vendor. That vendor is D-Wave Systems, a company based in Vancouver and the US. Their latest model, the D-Wave 2, is a 512 qubit superconducting quantum computer. While its price tag of around $10 million puts it out of range of most users, Google has purchased one for use in its quantum lab. The superconducting material used in D-Wave's computer is a metal called niobium. By heating it and then rapidly cooling it, the metal exhibits quantum effects. The qubit's state of either +1 or -1 is represented by magnetic fields pointing either up or down. By utilizing tiny magnetic fields, they are able to configure the state of the qubit so that it can run calculations. 8 qubits are arranged in a grid-like pattern to form 16 points of interconnectedness. This grid formation of 8 qubits is called a qubit. The D-Wave system works as follows. Through a LAN or internet connection, they are able to program the computer. The computer is housed in a unit that is magnetically shielded and refrigerated. The refrigeration technology uses liquid helium in order to cool the quantum processor to a temperature approaching absolute zero. The D-Wave system uses a calculation technique called quantum annealing in order to make its calculations. Quantum annealing works as follows. The system is programmed with a problem that can be organized as a set of conditions to be met. The qubits, after being given the problem, arrange themselves in a way that they most efficiently solve the problem. That is, they remain at the lowest energy state needed to solve the conditions given. A problem with the D-Wave system is that the quantum state that it arrives at as a solution does not remain in that state for long. It degrades. This degradation is known as decoherence. Coherence, or the ability to retain a quantum state, is considered to be a key characteristic of a quantum computer. A possible solution to the problem of decoherence in quantum computers is to have multiple qubits run the same calculation. By having multiple qubits run the same calculation, you increase the length of time that they can retain the quantum state they arrive at. This benefit increases at an exponential rate as well. If you were to use about 1,000 qubits in order to perform the same calculation, you can retain the resulting quantum state forever. Quantum computers have many possible applications. They can be used to solve optimization problems. They can do statistical analysis and medical research as well. They also have applications in the areas of artificial intelligence and materials research, such as designing a superconducting computer that can work at room temperature. Somewhat paradoxically, quantum computers can also help us learn more about quantum mechanics, as even with all the research we've done so far in the area of quantum mechanics and quantum physics, we still don't know very much. The potential of quantum computers is boundless, and I, for one, can't wait to see where it takes us.
Yes, that is so true. Quantum computing, I think, in the future will be one of the greatest innovations, which will amaze us all. Well, as much as Michael and I have enjoyed your company, I hope you've enjoyed ours. And that's it for now. Please visit us again if you have anything new to tell you guys about. Thank you. Bye.